Okay, we're doing example from 7.4, and we have a data set of 105 body temperatures for adult humans, and we are given sample mean, so x bar of 98.1, and a sample standard deviation, the S, of 0.062. Now, what's the best point estimate for the mean body? Well, that's just our sample mean, 98.1. You can see I filled that in. So point estimate just means what's your sample mean, what can you guess at based on what you know, and in this case, that's our sample mean. Now, using sample statistics, we want a 90% confidence interval to estimate the mean body temperature. Does the confidence interval include 98.6? What does the sample suggest? So anyways, we first need to make a confidence interval around the mean. And now looking at our equations, you can see that here is our mean, and we're going to have to search for this E, because this x bar is going to be the 98.1 we found, and we're going to use E to search. But now we don't know the population standard deviation, so we don't have this, so we have to go to this one, and we're going to have to use the t-score. So we need to first look up the t-score. So here's our t-score table, table 8.3. You can also use Excel. If you look at my videos, you will see how to use Excel for this. So we start with degrees of freedom, and degrees of freedom is simply is n, the number of sample, minus 1. N was 105, so 104 would be degrees of freedom. You find whatever's closest, in that case that's 100 here. And then we want a 90% confidence interval. That means we have 10% left over in our two tails. So there's our two tails. So we come down this, come down, and we're here, 1.660. So this is our t-score. So then our E here is E equals 1.660. And then if we look at our formula, you can see what we're going to times it by is S divided by the square root of N. So going right to the next one, so S is 0.062, and this was just from our problem itself, over the square root of 105. So I'm going to do 0.62. I'm going to divide by 105, the square root, so then equals, times 1.660. Remember, this could be positive or negative. You always use the positive. So our E is 0.10044. And I probably don't need that many, but I like to always give myself a couple extra as I start working. And now we are going around 98.1. Remember, that was our X bar. So that means what I'm going to do here is I'm going to keep this, and let's go back over here. I've got too many screens open here. So this bottom one is going to be 98.1 minus 0.10044. Okay, so 97.9 or 98 degrees. Okay, then we're going to do the same thing, 98.1 plus now 0.10044. So that's 98.2. So 98.2. So this would be our confidence interval. So does this contain 98.6? Well, no, it doesn't. So what does this suggest? This suggests the mean is probably lower than 98.6. So obviously we've been told that mean body temperature is 98.6. This is saying something differently. For those of you in the nursing profession, I'm sure you know way more about this than I do. For example, it's just the process here that matters. So what do you need to do? Point estimate means mean, and they've given us this. If they don't give us this, if you give them data, you'll have to construct this. Since we don't know the population standard deviation, that means t-test. So we get out our formula sheet, and if you don't have this printed off, I would recommend you print it off. Simply plug in our formulas once we get that t-score. As I said, if you want to use Excel versus the table, see my other video, and it'll show you how. Let me get back to the right screen here. And then these are just questions about the problem as a whole. The important thing is make sure you can construct this confidence interval. So really all you're going to do is you're going to find the E, which involves finding the correct t-score. Once you have the E You just subtract it from your x bar, your sample mean, and you add it to your sample mean. So that's how you get the two sides of it.